and we're going to just be talking about one of those many graphs we did for the last 3 weeks. We're all set up for success here. Yay. So we're going to, this side is a reteach practice, and the back side is like a reading strategy practice, get you familiar with vocabulary. That was what was missing in the, our first module was all general ideas, bibbidi bibbidi boom. Now we're doing particular functions. So this guy, this absolute value function, is going to have a domain. It's going to have a range. He's going to have end behaviors. He might have zeros. He might be in intervals. We don't know. But he is a function, and we're going to transform it, just like we did. He does have an inverse. But if you remember your 1.4, the absolute value function didn't have, its inverse wasn't a function. Because once you flip it over that x equals y axis, it failed the vertical line test. So all that we're just going to talk about again and again and again. Okay? It says to graph that absolute value parent function, and that should sound familiar to you, right? The parent function is shaped like a V, and now we know its story. In Pickle in Module 1, we didn't always have a story. All they called it was the f of x, because they didn't want to tell you the details yet. Now we're getting into the details. They say for this graph, here's the equation that generated that V picture. Because all the x's, positive or negative, come out positive. So this is the output. Remember, the y is the output, the x's are the inputs. So everything that goes in comes out positive. Now you've seen these familiar notations, H and K. The original parent function has a vertex. I don't want to point there. I want to point at this guy. He has a vertex at 0, 0. Okay. Because there's nothing being subtracted on the inside and there's nothing being added on the outside. That's where we find the vertex for this V function. And so the new vertex, check my colors so I make them the same. Yeah, I'm going to make my H blue. And it lives here as the number that's being subtracted. All right. Might even zoom in a little bit on that. Just a little bit. Maybe. Nope. This one. A little bit more. There we go. Then the K is what's being added on the outside. And that's our game for the day. We're going to do some vertical stretching and compressing. That's happening down in the next example. But for now, we're just playing with the H and the K. So for this example, I'm taking that parent function and it's moving so that the H is 2. So that 2 goes here, looks subtracted because it is. That's the 2 guy. H is 2. That's what all that, whenever you see that, That's where the h lives, as the number being subtracted. And the k is the number that's being added outside. If you don't see something, it's 0, right? That's why the k up here was 0, because there was nothing in the parent function, nothing being added outside. Isn't that neat how that works? It's so cool. The equation shows you the new vertex. So it went over 2, right 2, not just over, but right 2, down 3. And Eureka, the new vertex. 2, -3. And that's where you look when you're picking the graph on the homework, where you look to see how the graph is transformed. The h is being subtracted and the k is adding outside the bars. The bars are the original function because everything that goes in that symbol comes out positive, no matter what. All right, and we've had this, we did this in Module 1. It was a tricky one though, was that stretching and compressing. Here they use the word stretch and shrink. They also use expand and compress, all those words, you know, synonyms, got to work on your synonyms. So if I'm going to vertically stretch or shrink something, my multiplier has to be on the outside of the function. So it's a number that'll be multiplied to the opposite value. So for this example, they ask us to stretch the graph vertically by a factor of 2. So the 2 shows up as the multiplier on the outside. Now the reason why they distributed it for this example is because their original function wasn't a parent function. It was just another function. So in our work, as we look, we won't be distributing that a. It'll already be distributed for us. It'll always be already be sitting there. Okay. Now, unfortunately, just like the homework, I can't give you all the examples, but thankfully they mentioned it here, that a horizontal, and I'm using pink, if you don't have pink, maybe a light red or whatever you got in your tools. That is when the factor is flipped. We don't have an example here, sorry. And you'll run into it, and please use your book. It'll give you more. There's not enough time in the world to show you everything. You just have to, some things you have to just notice and learn, right? That's a beautiful thing about life. But at least they mentioned it. That's why on the test they didn't flip it, you know, but on the homework they showed it flipped. So that's okay. We can do that. We can do that. We're not afraid. All right, so we've got to figure out, for this example, this graph started here and it was stretched vertically by a factor of 2. So they put the 2 in where the a was, and then since this wasn't the mama function, it wasn't the parent function, it changed the h of the original function to this. So, and that's okay, h is, I'm sorry, not h, k. It changed the k. There we go. There we go. So the vertex is at 0, 2. The reason why it's at 0, there's nothing, you know, there's nothing being added on the inside there. Okay. Now the domain for this is a rule, not a law. It's not like this is the way it always is. It depends on your story. Okay. Your story is the V's go out forever on an absolute value function. So the absolute value function domain is going to always be all x's for our purpose here in Algebra 2. Okay, so you can count on that. The domain without restriction is going to be all the x's in the universe, you know, on real number. Because it spreads out like that, right? Even if it's skinny, it still spreads out forever in both ways. But the range where it starts comes from the transformation. You see that was k? It's not that number, it's this number. That's where we got the range number. I didn't talk about that up here. Let me show you the range. You see how that is k, which came from here, which was here. It all that, the range comes from the k. The domain isn't affected by the h. I could start anywhere with my left and right place, and it still goes up forever both ways. Unless you put a restriction on it, you know. Okay? So whether I'm standing here, my arms are reaching to both sides of eternity, or if I go stand diagonally. Right? That's a beautiful thing. So you see why the domain's not rocked by the transformation, but the range is. Notice the greater than. That guy? Means he's going up. There was a negative outside. Going down. So he'd switch to a less than or equal to. This is the y story. From up to down. A multiplier outside here. A negative. Make it go down. Remember that from Module 1? Ish. All new. Right? You have to pay attention so you can connect what you heard before to what you're hearing now, and then you know you're going to hear it in the future. And see it as well. That's the lesson. Can we do it? Let's practice. It says graph each function, identify the vertex, domain, and range. The vertex is just the h and the k. That's the new vertex. And it's very handy when you're looking for the graph. You know, we get to draw ours, but you'll look for yours on the homework. So we just are practicing extra hard on our notes. So the homework will be a little simpler on the graph side. All right. So I go looking for my h. My h in this story is that number on the inside that's being subtracted. So that guy is the 1. The k comes from what's being on the outside. And that guy is the 2. Sorry about the fading in and out. I looked it up in the textbook. You could write the domain story 3 or 4 different ways. This is the 4th way, that the domain's always going to be all x for absolute value functions. So if we go 1 right, 2 up, and then nothing is stretched. Sorry, that's a really bad line. Haha. Okay. here, here, there we go, here, here we go, okay. Oh, it's fading really bad. Here we go. And remember, the range of story is where the K's start. Whoop. There's my 2. So it's everybody greater, on the y-axis greater than or equal to 2. There you be. Here's my 1 guy, right? He's there. I color him, he turns into a... That's pretty ugly. I don't know if I can make that a big fat 1 with a circle around it or not. Maybe I'll make it a 1 with, now I'll color it blue. Okay, here we go. That's just a lesson, my friends. What do you think? You know a lot already. I hope. H and K. Questions? Super. Aren't you glad you worked really hard in the last module? You're reaping your benefits of your thinking. For sure. Here's the tricky trick. What's being subtracted here? See that? See that? It's really a -3. So my new vertex has a -3. For the H, my new vertex has a -1 for the K. My domain is still all X because when I plot -3, -1, he's still, how do I know he doesn't get any skinnier or fatter? There's no multiplier outside here. So that's how I know it goes 1, 1, 2, 2, 3, 3. You know, it just like cuts across the boxes, right? Even Steven? That's how I know that. So I'm going to pick on my K guy. It's not flipped over. There's no negatives. So Y is greater than or equal to the K guy. That's where everything comes from. Yay! Clear as a bell. Clear as the water, not the mud. All right. Now the vertex. There's nothing being subtracted inside. So it stayed the original 0. Then the 1 is being added outside. So it, and you notice the 3 is just to the bars, it's not to the 1, so that's why it stays a 1, okay? And the domain is still all X. And the range has to do with the Y. It's not a negative. And it's a +1 here. Remember, if that was a negative, we flip that to less than or equal. Now we got to graph it. And I goofed this morning. I forgot about the 3 multiplier and I just went through my little boxes and someone kindly asked, what about the 3? So this guy is a vertical stretch of 3. So that means I'm going to put my vertex on 0, 1, 0, 1. But instead of going up 1 over 1, I go up 3 over 1. Then I go back. It's like a slope of a line, but it's not a line. It's a V function. So I can't call it a slope. It's a vertical stretcher. So now I get to connect these dots and get really skinny. And have a nice day. So that's what happened. I went up 3, right 1, and then I just did symmetry. You know, it'll match on both sides because the V is never awkward. If you remember from your homework, they gave you some choices where the V was weird, lopsided. That is not absolute value function. Because the absolute value of 2 is the same as the absolute value of a negative 2. And it never, you know, it's never not. Yay, math! So, but notice, you know what fooled me is I didn't have to play for the stretcher until the graph. I didn't need to worry about the stretcher for the vertex or the domain or the range because even if it's skinnier, it's still spreading out forever. That's why domain is all x or all real numbers or however you want to write it. Infinity to infinity. All that. Okay? So I promised you to see domain and range again. Here they are. The cool thing about the V function is keep your eye on the vertex. Watch it change if there's going to be a change. And like it said in the beginning of this, the whole graph shifts when the vertex shifts. Okay, ready for a little more practice? Some reading? This is reading strategies for graphing absolute value functions. It just has a really cool graphic. We can kind of color code. This is the parent function. And so we're doing absolute value functions. So when I ask you to draw an absolute value function, you could draw one for me. Definition of an absolute value function is from the vertex, the function extends 2 different directions in straight lines. And symmetrically, okay? Symmetrically. It's always, you should be able to fold it along a line and see the relationships. The vertex is the maximum when the function's pointing down like that, or the minimum when the function's pointing up like that. So remember when we did maximums and minimums, I didn't get to test you on them again. You will, or yet. You will see them again and again and again. So it just points out the fact that is called a minimum. It's the lowest point of the graph. Absolute value functions have a vertex hk in this form. So that's kind of a big deal. This one's just the original one, so there's no, the h and k equals 0. Okay? So in this one, for here, it's 0, 0, h and k. I can't say there's no h and k, they're just 0, 0. So on the original function, it's just f of x is bar x. Oh, and then I'm going to use the word always. They're pretty brave, which is true. As long as there's not an interval you're graphing over, you're fine. The domain is always all real numbers, and the range, has its limits. So the range for this one is y is greater than or equal to 0. Because remember, that's k. Remember, k was 0. You read it up the graph. Read it up the graph, right? Where does the orange start? At 0 on the y-axis. Isn't that interesting how they just came up with all this communication to describe this picture? So you know what you're talking about. Beautiful. So this is the transformation we're playing with. They don't have the B in there, but it could be. And you'll probably see it on your homework. You know that flip over B guy? So remember, that could happen as well. Not as often. You know, they're just being nice to you when they have the multiplier on the outside. Okay, so A was yellow. H was blue. Yeah. And K was green. And then, you know, this is just to help you. When I talk to you, sometimes the numbers are alike. And you go, which two are you talking about? So it just helps to have the colors too. So that obviously matches the H. So the vertex is 2. And there's nothing being added out here. 0. And your answer would be H equals 2. And K equals 0. That's why you picked that. Would the function given open upward or downward? Anybody have a conjecture? That's a nice word for guess. That's a scientific word for guess. What do you think? Knowing what you knew from Module 1, you see that negative multiplier, what did it do to the graph? Open up, still, or down? Now. Yes. Explain your answer. A is negative. That's my really ugly N. Kind of fun. Period. And my weird A and my funky E and my written I, and I'm all crazy. Okay. I'm going to put a comma here. I don't know, semicolon maybe? Is that the right punctuation? That's your explanation when you do that. I'm a woman of few words. You'd never guess it, right? Oh, so for number 3, let's see how they want us to describe how function moves in relation to the absolute value parent function. They want us to use words, I believe. Up, down, left, right. Yep, that's what they want to do. So remember that they're making the parent function the dotted one. This is all the parent function. I don't color, I scribble. There you go. And here's that one. Okay, so the newbie goes what direction, how many, any shout outs are fine. What direction is it moving? From the orange to the black, it's going what direction? And then it looks like 1, 2, 3. That's all they want. Next one, what direction? Somebody else. Thank you for your engagement. I need everybody to engage. What's the next one? How many? Or what direction? How many?
Yeah, 2.
So this one?
Yeah.
Okay. Every mark is 2. So it would be what direction? Up, down, left, right.
From the solid line, right?
Up. From the dotted to the solid.
Up.
It's fine. Up, and then it's halfway between 2 and 4, so it would be just. Do you see? Do you see 3 or no? Can you see 3?
Yeah.
Okay. I didn't want to make sure. Okay, that's why I'm asking, because I want everybody to see what I'm seeing. But if you're not looking, can't happen. Okay, this is a twofer. You usually say that way first, and the number, and then, and right 3 and down 3, okay? They did not ask us to write an equation, but I'm guessing you can. Oh, it's the G. Let's call it the G. This is extra. This is freebie. G of x is bar x plus 3. G of x is bar x. Oh man, I'm in a hurry. Can you guys see? Bar x plus 3. A lot of you guys got that wrong on the test. That's left 3, and that's up 3. You guys got those. It's easy. It's easy because it's new to you guys. But you can fix it. That's why I'm all about that. Right 3. If I could draw a bar. Down 3. Have a nice work day tomorrow. Okay? Keep in contact with me. If you have an assignment you don't like or you didn't finish, tell me to reset or open and how long. Give me the days. You're in charge of your grade.